Imran, you are not audible at all. Please check your mic.
Hello. Hello.
You are still not audible, Imran.
अपने वाइट वाला हेडफोन लेके आ.
Can you remove the earphones or anything you are using? Then try speaking.
Hello.
Yeah, you're audible now. Hello. Hello. No,
Hello.
you are very low voice. It was better in between. Now again, it's completely gone.
Hello.
Yeah, you have a low voice. You can text like last class. If you don't have any other earphones or anything like that. If you have, please change. If you don't, then use chat option.
हेडफोन लेके आ
Okay.
लिया.
Am I audible?
Hello, sir. Hello. Hello.
It was. You can use the chat option. Okay. Hello. Wait a second. Let me ask Mr. Sir if we can hear you. Give me 2 minutes. Imran, can you hear me? You can use the chat option. Can you try speaking something?
Yes, sir. Yes, sir. I am. Can you hear me? Can you hear me, sir?
Hello.
Hello.
Wait, Imran, give me 1 minute. Imran, try speaking something.
Yes, sir. Can you hear me?
Getting your voice, but it's very low. Can you use the chat option? Imran, can you use the chat option? If you can hear me, just type yes.
Hello, sir.
Going down, I cannot hear you. Or even see the chat.
Hello, sir.
Yeah, Imran, give me 2 minutes. Let me reconnect also. Okay. Yeah, Imran, try speaking something.
Yes, sir. Yes, sir. Yes.
Yeah, try speaking now.
Hello, sir.
Yeah, now you're audible. Finally. Okay, let's start. Okay, let's start. So we are clear with everything I taught you in last class.
Yes, sir.
Okay, then let's move further. Using matrices to represent linear transformation. What linear transformation means is if we have to shift a point, suppose this is a point, okay, x1, y1, z1, you have to shift it to x2, y2, z2. How to use matrices in transforming this? Okay, so the general pattern is P is a matrix. This is called transformation matrix. You multiply this with the matrix you want, the point you want to transform, then you finally get the result, right? Some magnification factor or like this. We'll get this by giving an example, right? There is a transformation matrix. Just focus on this. There is a transformation matrix. This is the point you want to transform. This is the final transform point, right? Transformation matrix, the point you want to transform. This is the finally transform point. Is it clear?
Yes, sir.
This is called image of the point, right?
Okay.
Okay. So let's jump to question. See, there is an question. Okay. Given that T transform x, y, z to x plus z, y, x plus 2y plus z. Suppose this is the question, right? They are asking find T and C. In three-dimensional space, there are three axes: I axis, J, K, right? I vector, J vector, K vector, right?
Yes,
You
sir.
know this, yeah. So we have to find all the transformation in these three coordinates, right? So what will you know that the I vector is represented by this, the J vector is represented by, and K is like this, right?
Yes.
Okay. So now let me write this. If we have to find the transformation of this point according to this equation, this condition, then it's very easy. Can you take a guess? If you have to find the first transformation of I vector, this will be transformed to, see, the value of x here is 1, y is 0, z is 0 in this case, in this particular case, right?
Yes, sir.
Then see, this is transformed into this, and this is x plus z. Let me write z like this. This is 2y. X plus z, that means 1 plus 0. This is y simply, and this is x plus 2y plus z This is how it is transformed. Very simple. So 100 is transformed to 101, right?
Yes.
The same way you can find of this and this. This is very simple question, right?
Yes, sir.
And when there is a transformation matrix, suppose there is a transformation matrix like this, A, B, C, F, G, then this column represents the I vector. This column represents the J vector. This column represents the K vector. Are we clear with this?
Yes, sir.
Okay. So coming to next question, the question says the transformation T transforms R3. This means a point in 3 dimension to a point in 3 dimension. T is a transformation matrix which transforms a point in 3 dimension to a point in 3 dimension. This is what it reads, right? The point with position vector 1, 0, 0. The point with position vector, that means this is to transform, is transformed by T to the point with position vector 3, 4, 2. This is transformed to this, they are saying. Okay, this is the question. The second part says 1, 1, 0. This point is transformed to 6, 1, 5. This is in matrix side, like 6, 1, 5. Are we clear?
Yes, sir.
And there is a third point also. Then they are saying the point with position vector 2, 1, minus 4 is transformed by T to the point with position vector 1, 1, minus 1. They have given you 3 points and the transformed points, the image of the points, right? They are asking you to find the T transformation matrix. How are we going to solve this, right? Suppose T is A, B, C, D, E, F, G, H. Wait a minute. Wait, एक second. Yeah, Imran. Okay. A, B, C. If the transformation, you are able to hear me, right? Hello.
Yes, sir.
Yeah, you are able to hear me, right? Sorry for that. Someone is calling. Okay. Yeah. Suppose the transformation matrix is this. So now we know the equation is like this. Transformation matrix, the point you have to change is equals to the changed point, right?
Okay.
Okay. So here the transformation matrix is A, B, C, D. And the first point we have to change was 1, 0, 0, right? I told you this point was transformed by T to another point, right?
Yes.
So this into this is equals to the changed point was 3, 4, 2, right? Did you understand this
Yes,
equation?
sir.
Okay. So see, this is a 3 by 3 matrix. This is one matrix, and this is, so the multiplication of this will get 3 by 1 matrix. We'll equate this and we'll get the answer. So multiply these two matrix. Tell me the answer. Multiply these two matrix and tell me the answer. What matrix will you get?
You have to say the matrix dimension or just the
Yeah, no,
answer
the
in general.
elements. The dimension is 3 into 1. This is very easy. I know you know it. Just tell me the elements I have to write. The final answer of this multiplication. This into this.
It is with the middle row, right?
What?
It is the middle row, right? The
Middle
middle
row.
row, B, E, N, H.
No. See, how do we multiply the matrices? Like this. This into this, right? So A into 1 is A, plus B into 0 is 0, plus C into 0 is 0. This is the first element. The second element would be D into 1 plus E into 0 plus F into 0. The third element would be G into 1 plus H into 0 plus I into 0. Right?
Yes.
Okay. So what we have here is this, right?
Yes.
So you can deduce from this or equate, and you get A equals to 3, D equals to 4, G equals to 2.
Yes, sir.
Replace this value in the transformation matrix we assume to be at base. We assume the transformator matrix to A, D, G like that. We got the value of A, D, and G as 3, 4, 2. Right?
Yes.
Now we know that this matrix will use the second point. The second point was 1, 1, 0. And this was transformed into 6, 1, 5. Right?
Yes.
Now again multiply these two matrix. Tell me the answer. The first and second matrix, multiply those. I taught you multiplication, matrix multiplication in the last class.
I have to include the first one as well, 3, 4, and 2.
Yeah. Completely. This matrix into this matrix. You have to multiply this matrix and this matrix. This is simple matrix multiplication. You know how to multiply matrices, right? We did that in last class.
Yes.
Yeah. Simply multiply and tell me the answer of the matrix multiplication.
Is it just the first two rows as the answer? When I did multiplication, I'm getting 3b0 4e0 240.
No, no,
Is
no,
that
no. Please recheck, recheck. It will
okay?
not be 3b0. No, no, it's not like that. It's 3 plus b plus 0.
Yes, I'm getting like
This
that,
is
but I was just telling the metrics. Like after I did multiplication.
Mhm. So the matrix you will be getting is 3 plus b plus 0, 4 plus e plus 0, 2 plus h plus 0, right?
Yes, this all combined in a 3 to 1.
Yeah. So this is a 3 to 1 matrix, right?
Yes, sir.
Okay. So this is equals to this, right?
Yes, sir.
So now equate these two and tell me the answer of b, e, and h. You can equate this two, right? This is 3 plus b, 4 plus e, 2 plus h equals to 615. So we can equate this equals to this. This equals
3
to this.
minus 3 and 3.
3 minus 3 and 3.
Yes.
Okay. Now replace this value into the matrix we formed. The first we had answer 342, right? 3.
So where did we get the equal to values like the 615?
This is the transform point. See the question. The point 110 was transformed into 615. I wrote down the question, right? I wrote down the question first.
Yes.
The equation is t x equals to y. X is the point that is to transform. Y is the transformed point.
Okay.
Okay. So 615 is the final point we get after the transformation.
So what was x?
X was the point that was to be transformed. There was a point in space. It was to be transformed by the matrix T so that we get a point Y.
So we don't like have a general value, a general matrix.
No, no, no. There is no general. See, there is no general concept. Like you need to transform the points according to your conditions, right? According to your questions, your needs. So there is always a different point and different transform point and a different transformation matrix.
Can you write it for the first one again? For the 342?
342. Okay, let me write that. I think I have that on screen. No, I don't. See, I assume this is my transformation matrix. I suppose it, right? The point that was to be transformed was 1, 0, 0. This is the point that is to be transformed. Okay, by which matrix? This matrix. That is why it is called the transformation matrix. All right.
Yes, sir.
And the transform point was 3, 4, 2. What this means is this point is transformed into this point 3, 4.
Was
These
that
are,
point already given? 342?
yeah.
Or
This is,
did
I wrote down the question, right? The question. Let me read the complete question. The point with position vector 1, 0, 0 is transformed by t to the point with position vector 3, 4, 2. All right. The point with position vector 1, 1, 0 is transformed by t to the point with position vector 6, 1, 5. This is the second equation we wrote. The final point was the point with position vector 2, 1, minus 4 is transformed by t to the point with position vector 1, 1, minus 1. See, 2 will always be given out of 3. This is one matrix, this is one matrix, this third matrix. 2 will always be given so that we can find the third matrix. All right.
is this question from the book?
Yeah. This question is from the book. This is example 15, page number 154. page number is from the book, not PDF.
Okay, sir.
Yeah, you can check. All right. So we got the points of ADG as we had ADG. Can you tell me? I actually forgot what ADG was. With the value of A, let me just write.
342.
We had the value of A, D, and G as 342.
Yes.
Okay, 342, and we got B, C, H as 3 minus 3, 3, right?
615. It
No,
was 3 minus 3 and 3.
okay, and this is E, F, I. Right? We are writing the third equation. Okay, so the point 2, 1 minus 4 was transformed into point 1, 1 minus 1. Right? This point was transformed into this point by this transformation matrix. All right.
Yes, sir.
So now again we have to multiply this two. This is 4. Again you have to multiply this two matrix and see what you get. Tell me the answer. Multiply this two. Simple matrix multiplication.
Nine minus 4C,
9
5
minus
minus 4F, 7 minus 4I.
8, 5 minus 4F, right? 4 plus 3, 7 minus 4I, right? This is equals to 1, 1 minus 1. Now again equate these two and find the value of C, F, and I.
Two, 1, 2.
So this is the transformation matrix we have. T equals to this, right? This is the answer to first one. They asked you find T. So we found T. All right. The second part asks find the image of the point with position vector -1, 3, 0. They are asking you to find the image of this point. So how to find the image? Can you take a guess? See, the equation is very simple. Just remember this equation. This is the transformation matrix into the position that is to be transformed, the point which has to be transformed. This is the final point, image of the point. This is a simple equation, right? This is multiplication. So if you have t and they are asking you to find the image of some point, they are asking you to find y, they have given you x, then what do you have to do?
Y over T.
Y over t. No, they asked you to find y, right? They asked you to find image.
Yes.
You have t and x, right? This is t and this is x.
Yes.
So what is the step? How to find y?
Just multiply them.
Yeah, right. Multiply them. So 3, 3, 2, 4 minus 3, 1, 2, 3, 2, and minus 1, 3, 0. Multiply them. The answer will be y. Are we clear now? See this equation. This is a matrix, this is a matrix, and this is a matrix. These are multiplied, right? We don't write in multiplication like this in matrix. This is simple matrix multiplication. This is the transformation matrix. Always there is the conditions you have to apply. X is the point that you want to transform. Suppose I ask you transform this point, then this is X. If I say the transformed point, the image of the point is, so this is Y. Just figure out what the quantities are given, put those values here, and you will get the answer. Are we clear?
Yes, sir.
Okay. So can you multiply this? Tell me then, multiply this too.
Six minus 13, 7.
Yeah, absolutely right. So now are we clear how to use this transformation matrix in equations?
Yes, sir.
Okay. So shall we move forward?
Yes, sir.
Okay. Now you are going to use the inverse of a matrix to use the linear transformation. Suppose now they ask you the transformation matrix is, suppose the same question, right? If they ask you if they ask you why is there, they tell you the image of a point is 6 minus 13, 7. The transformation matrix is this. Find the point that was transformed, right? They ask you to find x. How are you going to find? This is very simple. If I multiply t inverse both sides, this is identity matrix, right?
Yes, sir.
So this is how we are going to find x. X equals to t inverse y. Are we clear?
What happened to the identity?
Identity is 1, right? So identity into any matrix is that matrix. That is why it is called an identity matrix. If you multiply any identity matrix to any matrix, answer is the same matrix. That is why it is called the identity matrix. Clear?
Yes, sir.
Okay. So this is the formula or equation you are going to use to find the answer. So in this question, I gave you the value of y, the transformation matrix. Can you find x? Although we have the answer here, but still, can you find the value of x? What equation are you going to use? X equals to t inverse y. You know the value of y. We have to find t inverse, and to find the inverse of a matrix, we solved it in the next previous class, right? We learned how to find the inverse of a matrix.
Yes, sir.
Yeah, so find t inverse. Shall I give you another question?
Okay.
If the transformation matrix is this 1 0 2 0 2 0 1 0 1, okay, they are asking you to find the vector a b c is transformed to the vector -3 4 2. They are asking you to find a b and c. This is the transformation matrix. They are asking you this was transformed to this. So what is y here? Y matrix?
It's -3, 4, and 2.
Absolutely right. So what equation are you going to use?
Uh, Inverse t and y equals to x.
Absolutely right. Absolutely. So find x, please. Calculate it fast. You have to first find t inverse, right?
Yes, sir.
Yeah. Please solve it.
Seven, 2, and -5.
Wait a second. You are telling me the final answer.
I'm telling the answer of x.
That was very fast. You calculated T inverse by yourself.
Use the calculator.
You use the calculator. You didn't write the steps.
I've written the steps. I did t inverse first. I first found the
No.
determinant and then I did t inverse.
Okay. How did you find T inverse? Like you completed the steps like cofactor, minor cofactor, etc., or just put it in the calculator?
I did the determinant times t. 1 over determinant times t to get the inverse.
Okay. Determinant times T. Uh, is that how we learned how to find the inverse?
You have to do the cofactor as well for the 3 by 3s.
Yeah, yeah, right. I told you 5 steps, right? First to find determinant T, then to find minus, then cofactors. Do you remember?
Yes.
Then transpose. Then the final step was to 1 over determinant T into this transpose, C transpose, right?
Yes, sir.
You cannot put it into calculator and tell me the answer. You have to solve it by yourself in the exams, right?
Yes, sir.
Okay. So let's do one question from the exercise. Okay. T equals to 2, 0, minus 3, 0, 1, 2. This is transformation matrix. They are asking the vector A, B, C is transformed by T to the vector minus 5, 5, 60. You have to find A, B, and C. Okay.
Do I say the value of t inverse or x first?
Tell me the value of t inverse.
I got 2 minus 1, 1 minus 2, 7 over 3, minus 4 over 3, 1, minus 2 over 3, and 2 over 3.
Okay, actually I don't have the answer of this. So can you tell me the steps how you did this?
First, I found the determinant. Determinant
The
was
value
3.
determinant you had 3. So 16, 28, so 0, then minus 20. How did you have 3 determinant? Wait, 2, 8.
What is the answer for the determinant? Is it something else?
Let me wait just a second. Yeah, this is plus, right? Plus 9, I think. How did you calculate? Did you see this is minus 3 into 0 into 1, 0, minus, yeah, right. You are right. So this is 3. Yeah, next step.
Added the minus sign.
To which? To what?
To 2 and 1, and there's 0, 0.
No, first you have to find the minors, right?
Yes. Yes.
And what is the answers of them? Minor matrix. The first is 6, right? 8 minus 2 is 6. Did you find the minor matrix?
No, I didn't find the minor matrix.
Then how did you find the inverse? The second step is to find the minor matrix, right?
Yes.
Do you remember how to find the minor matrix?
Yes.
Then tell me the
For
answers.
2, for 2, the minor is 1, 2, and 1, 8. I have to just cross multiply them.
Yeah, right. So tell me the minor matrix completely, all the elements. What should I write here?
So mine plus 6 or minus 6.
Plus 6 or minus 6? This is your answer?
Yes. Yes.
Plus 6 or minus 6? What is the final answer?
This is plus 6.
Plus 6. Okay. Here, third element.
3.
3. Yeah, right. Here,
Minus 3.
minus 3. No, this is plus 3. Again, see, this is gone, then 0 into 8, 0, plus 3. Right? You always multiply like this first.
Yes.
So this is plus 3. Okay. Here,
7.
yeah. Here,
2.
Yeah. Here.
Plus 3.
Yeah. Here.
4.
Yep. Now last one.
2.
Yeah. So you have the minor matrix here. Next is what is the next step?
To put the minus sign.
Yeah, this is called cofactor matrix. Finding the cofactor matrix. The cofactor matrix would be, tell me the answer.
6 minus 6, 3 minus 3, 7 minus 2, 3 minus 4 and 2.
Yeah, right. Now the next step.
To transpose it.
Yeah, right. C transpose. So the answer is
6 minus 3 and 3,
okay.
and then minus 6 and then 7, and then minus 3.
Again here minus 3. I think. See, just write this here and this here, this here. So here minus 4 is there, right?
Yes, so minus 4, 3 minus 2 and
And the final step is to
multiply it with the 1 over determinant.
yeah, right. So the T inverse we have is multiplying by 3, we have 2 minus 1, 1 minus 2, 7 over 3 minus 4 over 3. The last would be 1 minus 2 over 3, 2 over 3. Okay.
Yes, sir.
This is the way you have to calculate the steps. All right.
Yes, sir.
Okay. So now, did you find the x?
I got it as 1, 1 over 3 and 7 over 3.
Let me check the question. Just multiply with what was the number? Minus 5, 5. I
Minus
don't need
5,
to.
5 and
Mhm.
16.
Okay, I don't need to check the multiplication, right? You calculated that right, right?
Yes.
Okay. So are we
Check the
clear? How
answer.
I actually don't have the answers. I have to calculate to check the answers.
Okay, sir.
Okay. This is a question from the book only. So if you have the answers, you can check.
Which question?
This was question number 3 from exercise 6E.
The exam question, right?
Yeah, question number 2. Sorry, question number 2. Exercise 6E. Page number 163.
Can you go back to what you wrote as the question?
I don't write the question. Actually, I rubbed it down, I think. See, question number 2. You can check the page
Because
numbers. Mhm.
I wrote it as for the, you can see the middle row, right? 0, 1 and 2. For the 2, I wrote minus 1.
We wrote minus 1.
Yes, because you wrote it here.
I wrote it minus 1.
Yes, I can't see it. You can see it in
Actually,
recordings.
okay, okay. So no problem. We solved it by that question, right? I don't have the answer. We solved it by ourselves. So no issue there. We solved a different question. It doesn't matter, right?
Yes, sir.
Okay. I wrote it -1. Maybe. No issue. Okay. Now, are we clear with these steps? How to find the inverse of a matrix and use the linear transformation in matrix?
Yes, sir.
Okay. You are doing your homework?
Yes, sir.
Okay. Now the eigenvalues and eigenvectors of a matrix. What this means is you are connected, right?
What, sir?
You are okay. Hmm. What eigenvector means that there is a vector to every matrix where if you apply linear transformation, what we learned just now, if you apply that, it just scales by a factor, right? Like if you had 2, 3, 5, then it just scales a factor by 5. Suppose it doesn't change or transform the points. Are you getting my point? See, till now, when we are applying the linear transformation, a point was changing, right? We are getting an image, right? But in eigenvectors, if you apply linear transformations, then it just scales to a factor. Like if you multiply 3 to it, it doesn't change in direction. The directions are same. Are we clear?
We are adding 3, right?
I'm multiplying 3. And 3 is just an example. It doesn't have to be 3. It can be any factor, 2 by 3, 4, 5 by 4, anything. But it doesn't change in direction. That is what it matters. If you apply linear transformation to eigenvectors, it doesn't change its direction. It is just factored by a number. And that number is denoted by lambda and is called eigenvalue. Are we clear?
Yes, sir.
Okay. So you can see if there is a matrix A, the transformation matrix, and X is the eigenvector, then it just increases by a factor, right? If you apply linear transformation to eigenvectors, it just increases or get factors by lambda, right? This is the equation. Ax equals to lambda times x. Do you understand this equation, what I said just now?
Yes, sir.
Okay. If you apply linear transformation to eigenvectors, it just gets factors by a quantity, and that quantity is called eigenvalue. Very clear?
Yes, sir.
See, in this equation, I can multiply an identity matrix, right? I can write it like this because identity matrix is just treated as number 1. It can be multiplied with anything, right?
Yes, sir.
Now taking this quantity to the other side, ax minus lambda times this equals to 0. Now taking common, a minus lambda times I equals to x equals to 0, right?
Yes, sir.
What we have to know about eigenvector is this is a non-zero vector. That means this cannot be a zero matrix, right?
Yes, sir.
But also you have to remember that eigenvalues can be 0. So lambda can take 0 as value, but x cannot be zero matrix, right?
Yes, sir.
So if I'm multiplying two matrices and getting a zero matrix, that means one of them has to be a zero matrix. And we know that x cannot be a zero matrix. That means a minus lambda times I is a zero matrix. That means determinant this is 0. right?
Okay, sir.
This is called the characteristics. You can write it down. Please write the steps.
Yes, sir.
Okay. See, this equation, determinant A minus lambda times I, is called characteristics equations of A, right? If they ask you to find the characteristic equation of a matrix, you have to find this. All right. You have to calculate the determinant of this, put it as 0. That equation would be called characteristic equation of A. All right.
Okay, sir.
Then the value of lambda, when you calculate, that would give you the eigen value. All right.
Okay, sir.
Did you write it down completely?
Yes, sir.
So if they ask you to find characteristic equation, just find the determinant of this, put it into 0. That is the answer. If they ask to find the eigenvalues, then calculate the value of lambda also. You have to calculate the value of lambda, right? And that we'll learn in next class. Matrix would be completed. All right.
Okay, sir.
Yeah, please complete your homework. You can do next 2 exercises, I guess, right? The linear transformation part. All right.
Okay, sir.
Okay. Take care.
Okay, sir. Thank you, sir. Bye,
Yeah.
sir.